So this is the revision video of acid, bases and salt, and this is the most important topic for all the paper, especially ATP, that is called P6. Okay, so the common properties: acids, they are proton donor, and what about bases? They are proton acceptor. So when the acid is proton donor, so the hydrogen ion will decrease from reactant to product side. As the bases are proton acceptor, so the hydrogen ion will increase from reactant to product side. Now look at this equation. HCl react with ammonia and they are going to form, this is called ammonium ion and this is called chloride ion. Now compare the number of hydrogen ion. HCl has just one hydrogen on the reactant side, but on the product side chloride has no hydrogen. What it means? HCl has donated the hydrogen. Now look at ammonia and ammonium ion. In ammonia there are 3 hydrogen atoms, but in ammonium ion that becomes 4. It means ammonia has accepted one hydrogen ion, so ammonia is base and hydrochloric acid is an acid. Some other properties: acids have pH less than 7 while bases have pH more than 7. Now what about the indicators? In acids the blue litmus paper turns red, but in case of alkalis or bases the red litmus paper turns blue. The second is thymophthalene. This is the new indicator added in your syllabus. It is colorless in acid and it is blue in alkalis or bases. The next one is methyl orange. This is another indicator. It turns red in acid and it turns yellow in alkalis. The next is about the definition of strong, weak acid, strong and weak alkalis. So what is a weak acid? It is partially ionized. Partially mean incomplete. It's given less number of protons. This is also called hydrogen ion. The pH value will be high. It's mean 4, 5 or 6. They are not dangerous. There are so many weak acids that we are using. You are using lemon that contain citric acid. Using milk that contain lactic acid. Okay. Vinegar that contain acetic acid. So these the weak acids are not dangerous. The examples: all organic acid, or you can say carboxylic acid. All organic acids or carboxylic acids are weak acid. The best example is acetic acid, propanoic acid, butanoic acid. Now the strong acid, they are completely ionized. You can also use the word dissociated. Dissociated and ionization mean same, giving more proton, more hydrogen. The pH value is low, it's 1, sometimes it's 2, and they are dangerous. They can react with our skin as they will dissolve the protein. The common example of strong acids are, it is hydrochloric acid, it is sulfuric acid. The next one is nitric acid. Now the strong alkali or base, completely ionized, accepting more proton are giving more hydroxide ion. The pH value is very high, it's 12, 13 or 14, and the strong alkalis are dangerous. The common examples are sodium hydroxide, potassium hydroxide. The weak alkalis, they are partially ionized, or you can say dissociated. Keep in mind, you can see the word ionized or you can see the word dissociated. Both have the same meanings. Okay. giving less hydroxide ion or accepting less proton. Low pH value, it's 8, 9 or 10, and these alkalis are not dangerous. And the common example is ammonia, or you can say ammonium hydroxide. Now we are going to discuss some reactions of acids and dissociation or ionization. Now this is called ionization or dissociation of an acid. We are taking two examples. One is hydrochloric acid. When it will dissociate, it will give its H plus. So you will get hydrogen ion, and the next is an ion, that is chloride. Now we are using organic acid, or you can say carboxylic acid. This is acetic acid. When we are talking about organic acid or carboxylic acid, it will dissociate the last hydrogen. It will donate this hydrogen. In HCl, hydrogen is at the first. In organic acid, we are talking about the last hydrogen. Okay, so this is the difference, and we are using two arrows. It means it's very weak acid. The reaction is reversible. It can be easily reversed. Now what are alkalis? Water soluble bases. And how you can identify? Periodic table is given in the paper. If the base contain the first group metal, or you can say the second group metal like calcium, magnesium, and in first group like sodium, potassium, these are always alkalis. They will be soluble in water. And how to dissociate an alkali? It will give you hydroxide ion split from here. Okay. Now we are talking about the reactions of acids. So generally we know about 3 reactions, but I have made it 5 just to differentiate in all the reaction. First is acid plus metal. You will get salt plus hydrogen. Acid plus base or alkali, you will get salt and water. Acid plus metallic carbonate, you will get salt, water and carbon dioxide. Generally we are talking about these 3 reactions. But these 2 are also the reactions of acids, but in these 2 reactions we are using oxides. So if an acid react with basic oxide, you will get salt and water, and if the acidic and basic oxide react, you will get just salt. Now look at the reactions. We are adding magnesium is a metal. It reacts with sulfuric acid. It is simply a displacement reaction. Displacement reaction. So this magnesium will displace this hydrogen. You will get magnesium sulfate and hydrogen gas. What will be your observations? A gas is formed. So you will see bubbles or effervescence. This reaction is exothermic, rise in temperature, or you can say the apparatus, the beaker, that will heat up. But all the metal don't react with acid. Now keep in mind the rules for displacement reaction, that more reactive metal will displace hydrogen, or you can say simply more reactive element can displace less reactive. So this metal should be more reactive than hydrogen. Now if you are adding copper with hydrochloric acid, you will see no reaction because copper is less reactive than hydrogen, so it can't displace hydrogen. The reaction is not possible. Second is, this is we are using now organic acid, carboxylic acid. This is acetic acid, and we are using calcium hydroxide. This is an alkali, as it is soluble in water. What is formed? Salt and water. Now look at the formation of this formula. CH3COON, it having -1 charge. Calcium is in group 2, so it has 2+ charge. So you will cross the oxidation state. And this reaction is called neutralization. What are the conditions for neutralization? There should be acid and alkali. The second is, when the acid react with metallic carbonate, we are using nitric acid. This is calcium carbonate, salt, calcium nitrate, water, carbon dioxide, again the gas is formed, so you will observe bubbles, or you can say the effervescence. The fourth is we are using the acid with basic oxide. Calcium oxide is basic. You will get salt and water. Secondly, the last reaction, we are using acidic oxide and basic oxide. You will get salt. Now I have written 5 reactions on the whiteboard. The second one is neutralization. What are the conditions for neutralization? Acid plus alkali. The first reaction is displacement, and reaction number 3, 4 and 5, these are acid base reaction. Now we are discussing the ionic equation for neutralization. It's a common question in your paper. So when we are talking about neutralization, H plus hydrogen ion from acid, OH ion from alkali, and they will form water. Now the reactions of alkalis are bases. The common reaction between alkali and acid, that is, they will form salt and water, and this reaction is called neutralization reaction. We have already discussed some example of this reaction. The second reaction focus on when alkalis mean water soluble bases, react with ammonium salt. Now what are ammonium salt? Any salt containing ammonium ion, all those salts are called ammonium salt. So when ammonium salt react with alkalis, they will form salt and water and ammonia gas. Okay. Now this is ammonium salt because it contains ammonium ion, and this is an alkali. This is salt, this is water, and this is ammonia gas. What will be your observation? Ammonia gas having a strong pungent smell, and keep in mind this is the only basic gas. So you can confirm this through by using the moist red litmus paper that will turn blue. Now oxides, the other topic of this chapter, binary compounds of oxygen. What is the meaning of binary? When oxygen reacts with any other element, the compound forms are called oxide. Carbon dioxide, calcium oxide, zinc oxide, sulfur dioxide. Now there are 4 types in your syllabus. The first one are acidic oxide. Oxides of non-metal, there are few exceptions that we will discuss later. Carbon dioxide, sulfur dioxide, nitrogen dioxide. Now what about their bonding? As acidic oxides are consisting of non-metals, so they have covalent bond and they exist in the gaseous state at room temperature. And if they are being used in the reactions, they will behave like acid. We have done some example. And if you are going to confirm these oxide as acidic, you will use the moist. Don't use the dry. The moist blue litmus paper, that will turn red. And sulfur dioxide and nitrogen dioxide, they are also responsible for acid rain. The second one are basic oxide, oxides of metal. But there are also some exceptions. But keep in mind, group 1 metallic oxide and group 2 metallic oxides are always basic in nature. Calcium oxide, magnesium oxide, you can say sodium oxide. Okay. As they are consisting of one metal, the other is non-metal, so they have ionic bond, and when they are ionic in nature, they exist in a solid form at room temperature. And if we are talking about their reaction, they behave like base in the reactions. Third one is amphoteric oxides. These are also oxides of metals, but those metals which are less reactive. For example, zinc oxide, lead oxide, and aluminum oxide. These are always ionic compound. They exist in the solid form at room temperature. Now, how to confirm that the given oxide is amphoteric? Now, keep in mind, it's a common question in your paper. You can't use litmus paper. You can't use pH paper. You can't use any type of indicators. Then how to confirm that the given oxide is amphoteric, they are only through chemical reactions. When the amphoteric oxide react with acid, you will get salt and water. And if the same amphoteric oxide react with base, again you will get salt and water. Now let me explain. You know the one compound is acid and you are getting salt and water. It means the reaction is acid-base reaction. So the other should be base. And in this reaction, we already know that one compound is base. So the first one should be acidic. So when amphoteric oxide react with acid, it behave like a base. When that amphoteric oxide react with base, it behaves like an acid. The fourth one, neutral oxide. They are oxides of non-metals. They don't have acidic character. They don't have basic character. And if you are going to check through litmus paper, you will get exact the pH value that will be 7. Nitric oxide, carbon monoxide and water, these are the common example of neutral oxide. They are covalent in nature, so definitely they should be in the gaseous form at room temperature. Now the other most important topic of this syllabus, this chapter, and that is salt. What is the definition? When hydrogen of an acid is replaced with metallic cation or ammonium ion, the compound forms are called salts. They are ionic compound because they are consisting of cation and anion. Now the common question about salt is that is preparation of salt. So for the preparation of salt, you have to memorize the solubility rules. All ammonium, all nitrates, all sodium, all potassium, all these 4 types of salts are 100% soluble. In chloride, mostly salts are soluble except silver chloride and lead chloride. In sulfate, the maximum sulfate salts are soluble except barium sulfate, calcium sulfate and lead sulfate. In carbonates are mostly insoluble except sodium carbonate, potassium carbonate and ammonium carbonate. In sulfide, again the maximum salts are insoluble except sodium sulfide, potassium sulfide and ammonium sulfide. So you have to memorize these. Now we are discussing the preparation of salt, the most technical topic but the easiest one. So for making a salt, first you must know whether the salt is soluble or whether the salt is insoluble. Then for making any salt that may be soluble or insoluble, you will use 2 sources. One for cation and the other one for anion. The salt may be soluble or insoluble. Now making soluble salt. Now in soluble salts, there are 2 methods. First is titration method. So if the salt contain what? If the salt contain sodium ion, if the salt contain potassium ion, and if the salt contain ammonium ion, you will always use the method of titration, and in titration we are always using acid and alkali, nothing else. Okay? And for example, we are going to make sodium chloride. This salt contains sodium, so we will use the process of titration. Now we need one compound for sodium and other for chloride. For sodium, we will use sodium hydroxide. For chloride, we will use hydrochloric acid because this acid contains chloride ion. This is the equation. Hydrochloric acid reacts with sodium hydroxide, forming sodium chloride and water. Now keep in mind, in titration method, you will use 2 steps. I will explain later. Now, first you will do titration and then you will do crystallization. Now for example, we are going to make sodium chloride. So we will take 20 centimeter cube of 0.02 mole per decimeter cube of hydrochloric acid in a pipette, and then we will take that in a conical flask. Now add in 2 drops of methyl orange. You know, it's a common indicator. The color will turn red. Now you will use another operator that is called burette. You have seen that. Slowly release sodium hydroxide from the burette drop by drop and swirl the conical flask. When in the beginning the color was red, when it turns yellow and at the end it will turn lighter yellow, stop adding sodium hydroxide from the burette. Now find the volume of sodium hydroxide used. You have noted the initial reading of the burette, now the final reading of the burette. Now find the difference. That will confirm that how many sodium hydroxide have been used. Now do this experiment. Repeat this experiment without using the indicator, because definitely then why we have used indicator? As acid and alkalis, these both are colorless liquids, so we can't see the end point. The methyl orange or any indicator will change its color, that will give us the end point of the reaction, and also now we can know that how much acid and how much sodium hydroxide are needed to make sodium chloride. So you have noted the amount of HCl, that was 20 centimeter cube. You have noted the amount of sodium hydroxide from the burette. Take those amounts, but now without indicator, just mix these both amounts. You have formed sodium chloride. Now this is in the aqueous form. So heat the solution till the point of crystallization, and there must be slow heating. We have done the point of water of crystallization, okay, using burner evaporating dish. You can further dry that salt between filter paper. We can also use the oven. Now you can see the crystal of sodium chloride. Making soluble salt without titration. If the salt doesn't contain sodium, potassium and ammonium, then we will use this method. For example, we are going to make magnesium sulfate. So we will use magnesium to get magnesium, and magnesium is a metal, so it's in the solid form. We will use sulfuric acid for sulfate. This is the reaction. Magnesium is in the solid form. Sulfuric acid, you will get magnesium sulfate plus hydrogen gas, bubbles. Now how to write the procedure? Take some amount of sulfuric acid in a beaker, adding magnesium oxide in excess. What is the meaning of excess? Keep adding magnesium. You will see the bubbles of a gas. When there is no bubble formation, it means the reaction has been stopped. Now don't add more magnesium, but you have added in the excess. Now there is a question. Any substance that has to be taken in the solid form should be taken in excess. Why? So that we can know the end point of the reaction, as we are not using indicator in this case. Now filter the excess amount of the magnesium by using filter paper conical flask. And what you will do, now you can do heat the solution. You will use evaporating dish, burner. Now dry the crystal between filter paper, and you can also use the oven. Now you have magnesium chloride, magnesium sulfate in the solid form. Now how to make the insoluble salt? So there is only one method, and that is called precipitation method. So first, what is a precipitate? When two soluble substances or salt react, the insoluble product formed is called a precipitate. Now for example, we are going to make lead to iodide. You know This is insoluble salt. So we need two soluble salts. So we will use lead nitrate to get lead, and we will use potassium iodide to get iodide. Now this is a reaction. This is lead nitrate. Just mix lead nitrate with potassium iodide. You will get, this is lead iodide, the insoluble salt. You will write S means it will remain in the solid form as it is insoluble, and potassium nitrate is aqueous. This is our product. Now how to write the procedure? Add the solution of potassium iodide in the solution of lead nitrate in a beaker. Just swirl or you stir for some time. The reaction will happen. You will see clearly a precipitate, and those precipitate are the precipitate of lead iodide. Now just filter the solution. What we are using for filtration? We are using filter paper, we are using conical flower, we are using a beaker etc. Okay. Now wash the precipitate by using distilled water. Don't use tap water because that contains so many minerals and your salt will become impure again. Now you can dry between the filter paper. This is how to form the insoluble salt. A very simple and a very short procedure. Now there are two definitions. Water of crystallization, number of water molecules attached to any crystal during the process of crystallization. For example, this is copper sulfate and it has 5 water molecules attached. Now what is a hydrate? A compound having fixed number of water molecules, those are chemically attached. And anhydrous, a compound when a hydrate is heated, that will lose water molecule and then that will become anhydrous. Now this compound is a hydrate because it contains 5 water molecules which are chemically attached to copper sulfate. Now when this compound is heated, it will lose the water molecule and now it will become anhydrous.